welcome you all. I am Dr. Kishanu Kundu, Assistant Professor, GL Bajaj Institute of Technology and Management, Greater Noida. Today, I am going to start the subject Digital Electronics, subject code KOE 039/049. So, first of all, we will start with the table of content of today's lecture. First of all, we will start with the overview, then we will start the number system, then the conversion of decimal to other number systems and from other number system to decimal number system. Then we will learn about the conversion between octal to binary, hexadecimal to binary and octal to hexadecimal number system. So, first of all we will start with the overview of the subject. What is first question what comes in our mind is what is the difference between analog and digital electronics. So, in analog technology the informations are translated into electrical pulses of varying amplitudes, but in digital electronics the information is converted into binary form. Binary, there are two forms, zeros and ones, and the labels are 0 is equal to lower level and 1 refers to higher level. Okay. So, next question comes in our mind that what are the advantages of digital electronics. First of all, in digital signals it can transfer more number of data per second, it is also faster than analog signals and digital circuits are also easy to design. Next, what are the application? From the smartwatch what you are wearing, then whatever you can see from rocket science to the traffic light controller, every places in mobile, in laptops, every places digital electronics is used. Next, scope of digital electronics. Digital electronics a foundation subject that is very much required for the subjects like microprocessor, microcontroller, and after getting knowledge of digital electronics we will get jobs in every field like aviation, like mobile communication, automatic control system, every places the jobs will be there after you go through this subject. So, let us start with number system. So, from childhood we all know that there are 10 numbers, right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, total 10, right. So, this is nothing but the decimal number system. What are the 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So, these are total 10. So, these are we already know about the digital number system, but in digital electronics we will learn about other 3 number system. They are binary number system, octal number system and hexadecimal number system. So, here I have written base. So, what is base? The base is the number of symbols that is being offered by a number system. So, here in decimal we are having base as 10. So, it is having symbols like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then binary number system the base is 2 because only 2 symbols are being offered by binary number system, zeros and 1. Then octal number system there are total 8 symbols offered by octal number system, they are 0 to 7, 0, 1, 2, 3, 4, 5, 6 and 7. Then last not the least hexadecimal number system. Hexadecimal number system total 16 symbols are being offered by hexadecimal number system. So, that is why the base is 16 and that is 0 to 9, but no 10 is there. You can see here it is up to 9 only. So, 10 is represented as A, 11 is represented as B, 12 is represented as C, 13 is represented D, then 14 is represented as E and 15 is represented as F. So, these are the 4 number systems are very important in digital electronics, and binary number system is basically used by machines, and octal and hexadecimal number systems are used for interfacing between the machine and human. Okay. Let us go to the next slide. Now, already I have told you that this is 1, 2, 3, 4. This is the decimal number system. You can see that base is 10. Whatever we are going to write a number system, we will write like this. This is the number and here we will write the base. So, for decimal this is 10, for binary it will be 2, for octal it will be 8, and for hexadecimal it will be 16, correct. Okay. So, now this is I can write, I have written here 1, 2, 3, 4, okay. Base is 10. So, now see the position, this is 0th position, 1, 2, 3, 4 we have written like this, this is 0th position, this is 1th position, 2th position and 3th position. So, now we have to multiply this with the base. So, 4 will be multiplied by 10 to the power 0, this is 0th position, then 3 into 10 to the power 1, then 2 into 10 to the power 2 and 1 into 10 to the power 3. So, total we are having 1000 plus 200 plus 30 plus 4. So, total is 1, 2, 3, 4, right. Next, similarly, in binary number system we are having only 2 bits, that is we are having only 2 bits, zeros and 1. So, here I have given an example 0 1 0 1 0 1 0 1. So, this bit is LSB, least significant bit, and this 0 is nothing but MSB, most significant bit. Okay, clear. So, thus here this is a 8 bit representation. So, bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6 and bit 7. Okay. Next, so in the above example we have seen only 8 bits are there, 0 to 7. So, group of 4 bits is called 1 nibble, then group of 8 bits is called 1 byte, and group of 16 bit is called small word, and group of 32 bits is called long word. Okay. So, now here we have also written the bit position. So, this is 2 to the power 0 means 1, 2 to the power 1 is equal to 2, 2 to the power 2 is equal to 4, 2 to the power cube is equal to 8, 2 to the power 4 is equal to 16, 2 to the power 5 is equal to 32, 2 to the power 6 is equal to 64. Everything will be in the 2 to the power n form, it will be in the form of 2 to the power n, right. So, like that in the previous example we have written 1, 2, 3, 4 and base was 10, here 1, 0, 1, 1. This is binary number system because base is 2 is given. So, like that we are going to multiply that, this is the 0th position 1, 2 and 3. So, here we have written like this 1 into 2 to the power 0 plus 1 into 2 to the power 1, then 0 into 2 to the power 2 plus 1 into 2 to the power cube, right. So, total we are getting as 8, then 0 into the power 2, 2 to the power 2 means 0, then 1 into 2 to the power 1 means 2 and 1 into 2 to the power 0 means 1. So, total we are getting 11. So, this is nothing but the decimal representation of binary number 1011, clear. Okay. Next, we will discuss about other number system. Already I have told in the previous slides that there are 2 number system, octal number system and hexadecimal number system. Octal number system base is 8 and hexadecimal number system base is 16. Okay. Octal number system 8 symbols 0 to 7 and hexadecimal number system total 16 symbols 0 to 9 and 10 is represented by A, 11 is B, 12 is equal to C, 13 is equal to D, 14 is equal to E and 15 is equal to F, clear. Okay. Next topic is conversion. First of all we will learn how to convert decimal number system to another number system. So, here I have written base B. So, base B can be either binary, either octal or hexadecimal. Okay. So, here I will give a general formula how to convert from decimal number system to other number system. So, here I have written a part like D, capital D comma small d base 10. So, suppose I am writing 48.18. So, here 48 is the integer part, D, capital D stands for integer part and small d stands for the fractional part. So, here 18 is 0.8. So, this is 18 is the fractional part and 48 is the integer part, right. So, what are the rules for conversion? For integer part, divide successively by base B and collect the remainders in reverse order. Collect the remainders in reverse order means here we are suppose we are converting into binary number system. So, then base will be 2. So, I have to successively divide 48 by 2 and whatever the remainders will get we will collect it and we will represent it in the reverse order. Once I give an example it will be very clear to you. Next, for fractional part, how we will describe? For fractional part we have to multiply successively by the base B. So, now again we are converting into binary number system and fractional part is 18. So, 0.18 will be multiplied by 2 and we will collect the integer parts, okay, and that same order we will represent it. So, let us take an example. So, here 25.75 is given as decimal number system and we are going to convert it in other number system like binary, octal and hexadecimal number system, right. So, I have told you the first rule is we have to first segregate the integer part and fractional part, and for integer part we have to divide and for fractional part we have to multiply. So, let us start. So, here 25, one second, we are taking 25 is the integer part and now we are converting into binary. So, we will be dividing by 2. So, first is 12 and remainder is 1, then 2 6 are 12, remainder is 0, 2 3s are 6, remainder is 0, 2 1s are 2, remainder is 1 and here 0. So, 1 will be the remainder. So, now we will just write it in the reverse order. So, reverse order is like this. So, we will 25 will be written in binary like 1 1 0 0 1, right. So, the integer part is done, integer part is done. So, now for fractional part. So, here we have written for fractional part we have to multiply with the base in which we are going to convert. So, here the base is binary. So, binary base is 2. So, we have to multiply it. So, let us start. So, here the fractional part is 0.75, we will multiply it by 2. So, here 10 0 then 1 15.1. So, this is the integer part. Now, we will carry on, we will continue the multiplication with this fractional part. Okay. So, fractional part again we will multiply 2 and this will be kept side. So, again we are taking as 0 0.1. So, again we are taking the integer part and again we are going to multiply. If we are going to multiply then it will be coming as 0.0. So, same order we will take. Here we are taking the reverse order, but for fractional part we will take the same order. So, previously we have got the result as 11001 for the integer part, and for fractional part we are getting 110. So, this is the full conversion of decimal to binary number system. Like same wise, if we want to convert in same number, we want to convert in octal number system. So, octal number system base is 8. So, we are going to divide the integer part with 8 and we will multiply the fractional part with 8. Okay, let us start. So, 25 if I divide by 8. So, 8 3s are 1, then 8 0, remainder is 3. Okay. You are writing like this. So, the for the integer part we are getting 31, we will collect in reverse order, and for now for fraction part. So, 0.75, 75 again it will be multiplied by 8. So, 0 4 6. So, we will sidetrack the integer part and we will again multiply this. Now, it will come as 0.00. So, for integer part we are getting 31, for fractional part we are getting 6. So, the answer will be 31.6 in octal number system. So, likewise we have converted the same number into binary and same number 25.75 into octal number system. Now, the last one is hexadecimal number system. For hexadecimal number system, again here the base will be 16, because we are going to convert in hexadecimal number system. So, base will be 16. So, we will now divide with 16 the integer part. So, let us start. So, my number is 25 and we are going to divide in by 16. Okay. So, 16, one second. So, 16 will be 1 and remainder will be 9, see 16, 0, remainder will be 1. Okay. So, 1 9 will be coming. Okay. Reverse order, reverse order, and 0.75 again we have to multiply with 16. So, if we multiply 0.75 with 16, so it will be coming as 12.00. Okay. So, 12.00. Now, again if we are multiplying this with 16, so it will again come 00.00. So, integer part is 12, but here you have to remember one thing, 12 does not exist in hexadecimal number. So, 12 represent equivalent to, I have already taught you, 12 represent to C. So, now we will write 19 point C. We will not write 12 because 12 does not exist in hexadecimal number. So, now we will be writing as 19 point C in hexadecimal number. So, like this we have converted same number in decimal into binary, into octal and into hexadecimal number system. Got it? Okay. Next. Next is conversion to decimal from base B, means till now we have converted decimal number system to other number system. Now, it is turn to convert from other number system to decimal number system, correct. So, here I have written here the general format. So, here the base can be binary for 2 for binary, 8 for octal and 16 for hexadecimal. Now, for conversion we have to multiply the base position with the bit or digits position, okay, and then we have to add all the individual multiplication results to get the decimal equivalent. Okay. So, let us start one example, then it will be easy for you. First we are taking 11001.11, it is in binary and we have to convert it in decimal number system. So, how we will convert this? So, let us start. from the with the base position. So, this is 0's position. I am writing here again 1 1 0 0 1.11. Okay. So, this is 0's position, 1's position, 2's position, 3 and 4, and this is minus 1 position and minus 2's position. Okay. So, now this is in binary. So, we have to multiply with 2, base position of 2. So, first is 1 into 2 to the power 4, right, because this is 4th position. So, 1 into 2 to the power 4 plus 1 into 2 to the power cube plus 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. Now, plus point, we are multiplying 1 into 2 to the power minus 1 and 1 into 2 to the power minus 2. See the previous slide, here also we have written the bits digit and then we are multiplying with the base. So, here the base is binary. So, we are multiplying by 2 like that. If the base is 8, so we will be multiplying with 8 position. If it is 16, then we will be by 16. Okay. Next. So, like that if I solve the problem, so it will be coming as 16 plus 8 plus 0 plus 0 plus 1, and for point it will be 0.5 and it will be 0.25. So, total we are getting 16 plus 8 plus 0.1, it will be 25 point, here 0.5, 0.25, it will be 0.75. Okay. So, this will be decimal. So, we are converting binary number system in decimal number system. So, we have converted like this. Similarly, if I are converting this, so 31.6. So, this is 0th position, this is 1 position, this is minus 1 position. So, now we have to multiply this with 8. So, we will be writing like this, 3 into 8 to the power 1 plus 1 into 8 to the power 0 plus 6 into 8 to the power minus 1. So, it will coming as 24 plus 1 plus 6 by 8. So, if we solve this, it will be coming as 25.75 in decimal, right. So, we have converted binary number system into decimal number system, then we have converted octal number system into decimal number system. You can do by yourself for 19 point C. So, first of all, C is not, we cannot multiply C, but C actually equivalent to 12 in hexadecimal number system. So, we will write like this 19.12 and this is 0th position, this is 1 position, but it will be taken as single one. So, this is minus 1 position. Okay. So, now multiply 1 into 16 to the power 1. Why 16? Because it is in hexadecimal. So, we have to multiply by 16. So, 1 into 16 to the power 1 plus 9 into 16 to the power 0 plus 12 into 16 to the power minus 1. If we solve it, it will be coming as 25.75. It will be coming as 25.75. So, like that we have converted all number system back to decimal number system. Is it clear to you all? This is 5. Okay. We are converted into all number system to decimal number system, correct. Okay. So, this is one short form I am taking 3-bit representation and 4-bit representation. If 3 variables are there, then we will come like that. 4 to 1 means 2 to the power 2 to the power 1 to the power 0. So, it will be coming as 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and triple 1. Okay. And 8 4 to 1 means to the power cube to the power 2 to the power 1 and to the power 0. So, we will be having 4 variables and that will be represented up to 0 0 0 0 to 1 1 1 1. Okay. So, this is the 3 bit and 4 bit representation. Next, conversion between octal and binary. So, if we are converting octal to binary, so we will be taking group of 3. So, 3 will be in previous slide you can see. So, this is actually 0, 1, 2, 3, 4, 5, 6 and 7. So, this is the decimal and this is the binary representation. So, 3 stands to 0 1 1. So, like that we will take as 3 is equal to 0 1 1, 1 is you can check from here 1 is 0 1 0 0 1. So, we will write 0 0 1 and 6 is equal to you can check 6 is equal to 1 1 0. So, we will write as 1 1 0. So, just like that you can represent 0 0 0 1 1 here 0 1 1 then 0 0 1 then here it will be having a this point. So, point 6 will be 1 1 0. So, this is converted into binary number. So, like that we have converted a octal number system directly to the binary number system. So, like that if we have to convert again it back to binary number system, again we will have take the grouping of 3. So, here the number is 1 1 0 0 1 0.11. So, see if we taking group of 3. So, this 3 will be grouped as like this, but here only 2 digits are there. So, again we will take assume one 0. Okay. So, it will be grouped like this and after point 0 has no significance. So, again we will put a 1 0. So, now 3 bit grouping is possible. So, 0 1 1 again it is 3 in decimal, it is 1 in decimal and this is 6 in decimal. So, now the octal equivalent of this number 1100 1.11 will be 31.6 in octal. Okay, clear? Similarly, we have to convert, it is in octal to binary you have done. Now, if we want to convert in hexadecimal to binary, then we will grouping as 4. In octal to binary we are taking grouping as 3, from conversion between hexadecimal to binary we will take group of 4. So, this one will be 0001, this 8421 code I have already told you, this is the 8421 code, this will be grouping of 4 numbers. Okay. So, like that 1 will be 001, 9 will be 1001 and C is actually equivalent to 12. So, C will be 1100. Okay. So, we will write that 0001 1001.1100. So, this is the binary equivalent of 19 point C. Okay. Next, like that if I convert into this into hexadecimal number system, then we have to again grouping of 4. So, here after decimal 2 zeros will be connected, here this 4, but here we are not having only one bit is there. So, we will assume 3 more, it will be having no significance. So, this will be calculated as 1 only, this is 1, this is 9 and this is nothing but 12 means C. This is actually 12. So, this will be C. So, 19 point C in hexadecimal. So, like that we have converted all the number system into from binary number system to hexadecimal and hexadecimal to binary. Again we have converted octadecimal octal number to binary and binary to octal, and the main thing is the conversion of decimal number system to other number system and other number system to decimal number system. Okay. Thank you.